Okay, so today we're on site with Martin, who is our engineer. He is going to be commissioning 3 heat pumps on these new build properties. So we're going to take you through the process and yeah, his day to day really. So this is how it looks inside at the moment. Obviously the heat pump is outside, so we'll go check out that in a bit. But this is the pipe work at the moment. We'll see what Martin thinks. So this is Martin, one of our commissioning engineers at Alto Energy. So he's going to be taking us through the commissioning process and yeah.
So what we're going to look for in terms of where position of every component and what we're looking for, we can see in the back corner we've got the flow and return from the outdoor unit coming up. So this would be the flow coming up this way, where it transitions into the 3-port valve, position A down to the hot water tank, position B up to the low loss header. On the return, we have the filter strainer, we have the flow meter, and we also have the return circulation pump. We have a cold water supply over here, the combination valve. That comes down to the hot water tank and also goes up to our expansion vessel. We've got another expansion vessel for the primary circuit, which has obviously the pressure relief valve plumbed in as well. We've got our heating circuits over here. We've got our flow down to the underfloor heating manifold, which is under the stairs. And we have a flow with zone valve and circulation pump for our radiator circuit. Both of our returns come up here, common together, and into the low loss header. Our return from the hot water tank comes up, meets the low loss header return, and then it's common back down to the heat pump. Something to note when you're putting in a 3-port valve for a heat pump at a Samsung or a Mitsubishi is that it's the opposite way round from your traditional heating system. So whereas normally your priority port would be B, and that would go to your hot water tank, it's the opposite for these heat pumps, because we activate the valve to put it into hot water mode. So the A port has to go to hot water, and B goes up to your low loss header or your heating circuit. And that's something that can be unusual for builders, for plumbers that have been used to, installing boilers. We're looking to make sure that we've got the communication cable is connected and that they've got obviously the live and neutral in the right way. We've got an earth connected as well. Things we look for behind the unit is the level of insulation. We're looking to make sure that the pipes going into the wall have been cored out and that you've got insulation that actually goes into the wall. Any exposed, so this pipe work here, the insulation needs to be finished off. And it needs to be fully vapor sealed. My recommendation is to take the handles off of the valves, wrap around the whole thing. Any exposed metalwork is heat loss, but what we also, where the pipes go through the wall, they need to be insulated, because again, any exposed pipe work is heat loss. We've got flexible hoses connected under these bits here. This bit of insulation on the floor is it comes with the flexi hoses. Some installers take it off and will just use the same stuff all the way around. Most of them will use that supplied insulation. And again, so we'd want to insulate right up to the back of the unit. So this needs just a little bit of attention. I have spoken to the installer already and he knows about that. What we're looking for as well is that we've got means of any condensation that comes off the unit to get away from the unit. So they've got this bit of a channel around. Ideally, I'd say if they cut out a channel or remove this slab, it will allow any water that's sat down on the bottom here to just run away into the soakaway. This is setting the weather compensation settings. So what I've done with that is we've So we've set outdoor temperature targets, or outdoor temperature points, and then flow temperature targets at those points. So we've got 35 degrees flow temp at 15 degrees outside, then as it gets colder, down to -2, we then have 45 degrees. So in that outdoor temperature range, it will keep it within that sort of 10 degree temperature bracket. Then if a thermostat around the house sends a signal that it needs heat, it will see what the temperature is outside, and there's a sensor on the outdoor unit, and then it will then work out what its target flow temperature is at that point. It will keep on running until the thermostat is satisfied and stops calling for heat. And then we activate the hot water tank, and we'll also go through some settings for that. Maximum operation time, booster heater settings. There's a pasteurisation cycle that uses the immersion heater to boost the tank temperature up to 60 degrees once a week. We'll set that as well.
What's that for?
So it's to stop the potential for Legionnaire's disease. The little red circle at the front of the valve. Our little pointer is pointing down to position A, so we know that that valve is in the hot water position, which is what we want because it's doing a hot water cycle.
And how long does the hot water cycle take?
As long as it takes to get up to temperature.
Okay.
Obviously, because this is the first time it's turned on, start temperature for the tank is 22 degrees. We want to get it to 50, so that's going to take an hour or so to bring that up to temperature, and gives a 250 litres of hot water. We want to add a schedule, so we press OK again, and it will be a daily schedule. The type of cycle we're going to do is hot water, and then we want that to run on a standard program, and the first one I'll set is for 3 o'clock in the afternoon, and then we'll press OK. And what I want to do is set another program, so I'll go back up to add another schedule, go through the process again, and this one I'll set to 3 in the morning. We can turn our heating zones on by pressing the power button. Again, we can go across to hot water and turn that on. Press OK to enter hot water, and rather than be on economic, press to enter, and I want that on standard as well. The difference between the standard and economic programs: if you're in economic, then it will only use the heat pump as the power source to actually heat the water. Standard is it will use the heat pump as the primary heat source, but then if it starts to take too long, then it will use the immersion just to give it a bit of a boost. Standard is the common setting. So on the schedule, we'd say what the room is, the type of radiator. So this one here is, I'd say, is K1. So we've got one panel and a single row of convector fins, and then just get the dimensions, the width and the height in millimetres.
Is that just to make sure it matches what we've recommended?
Yeah, we can cross-reference what the output of this radiator is against what our design performance says that this area needs, and as long as they match or the output exceeds the design, we're happy. If it doesn't, then we have to go back to them and say that you've not got enough output from this radiator. Either it needs to be changed, or we need to adjust the design for a slightly different flow rate, a flow temperature, that then allows us to have that. But most of the time, that's spot on. Current temperature started off at like 22 degrees, so it's starting to climb up already, and that's only been not even 5 minutes. So if we feel around some of these radiators, we're starting to get some nice heat building up in the racks.
So this is the first property we were in.
Yeah.
Obviously Martin's done some work on the heat pump already, got it going. The radiators are all nice and warm now.
And that's been on for probably 35 minutes. And it's already bringing up the room temperature.
And the hot water's on as well, so that's nice.
We can see when we turned on this thermostat first time, it was reading 20 degrees, and that's up to 21.4 already. Right, that's this one done.
So we'll just go have a look at the actual heat pump running right now. As you can probably hear, not much noise coming from this. Maybe a bit from the helicopter that just went over, but the heat pump itself, not much noise at all. That's the end of today's video. So yeah, if you liked it, drop us a like, subscribe, and we'll have more coming soon.